Hello, this is session 22. This is the session for our pre-test for chapter 3. And we're using our pre-test here that you should be able to download from the files on Canvas, okay? This is pre-test for chapter 3. Number 1 says, how long does it take for a $5,000 investment to double if it's invested at 12% compounded quarterly? And then I even give you the formula for that, okay? So it's what could be easier. This is the periodic compounding. So we're going to use A equals to P and then 1 plus R over N to the NT. We'd like to insert 5,000 and we'd like to have that double, of course, to 10,000. The 12% I've changed to 0.12 for R. The N, the number of times we're compounding this is quarterly, so it's 4. And we're going to be solving this for T. So I did a few steps here to save a bit of time. I divided both sides by 5,000. You could have really started at this line if you wanted to. It's going to be 2, that's our doubling situation there, the periodic doubling. And it's 1.03, the 0.12 divided by 4 is 0.03 to the 4t. Then usually from here, I want to get you accustomed to using that natural log of 2. Take the natural log of both sides. You could take the log of both sides, doesn't make any difference. I've chosen the natural log. When you take the natural log of both sides, you remember the 4t will come forward. It's the exponent, so you'll be multiplying those two. To get the 4t alone, divide both sides by log, natural log of 1.03. That's right here, ln of 2 divided by natural log of 1.03. I've looked at it, didn't have to use the table for this one, natural log of 2. Now that's 0.693. If you use your natural log table, again, be careful which table you're using. The log tables and natural logs are not the same. The natural log of 1.03 is again about here. I'm looking at 0.030, so I just use 0.03 on that instead of 0.030. When you divide, maybe move the decimal 2 places above and below, basically 3 and a 69. That's about 23, and then the last 3, 23.1. Divide by 4 and 5.8, 5.7, somewhere around there. Good answer for you for the number of years it takes to double $5,000 at 12% compounded quarterly. Right, that's number 1. Number 2 says, what principal invested at 8% compounded continuously for 5 years will yield $3,000? So very quickly we go from the periodic compounding to the continuous compounding. That's of course our PERT formula, A equals to PE to the RT. And we'd like to know what principal we need to invest. So we're going to be looking for P, and it says so that you can yield $3,000. So that's what we want to end with, 3,000. So A is 3,000. And we're told that the continuous compounding percentage is 0.08, and also that we're told it's for 5 years. You put a 5. Simplify the 0.08 times 5 to 0.40, or just 0.4. And then basically looking for P, so you can divide both sides by e to the 0.4. I've again chosen to say you could divide e to the 0.4, we could find very quickly e to the 0.4, again from your e table. E to the 0.4 is about right here, e to the 0.40. Looking at 1.492, you could divide by that. Rather than dividing by 1.492, I chose to go to e to the negative 0.4. The e to the 0.4 can be moved to the numerator, becomes negative. So 3,000 times e to the negative 0.4. And again, back here to 0.4, and then e to the x, or e to the 0.4 is 1.492. E to the negative x, or e to the negative 0.4, is 0.670. So 0.670 e to the negative 0.4. What I did is I assigned the 3 zeros here to the decimal there, moved it 3 places basically. Becomes 3 times 670. That's not too bad to multiply. Turns out to be 2010, your answer there. $2,010 inserted now, compounded continuously at 8% for 5 years, should yield $3,000. Number 2. Number 3 is a thought question. And number 3 says that the bacteria in a 10-liter container doubles every 2 minutes. After 70 minutes, the container is full. How long did it take to fill a quarter or 1/4 of the container here? Well, I made a little picture for you here, And basically also on Canvas, the files, Canvas files, if you look under, I think it's Math 104, probably pretest number 3, container problem, and look for the CONT. I think you can't see it all because it kind of truncates the title there. It's toward the bottom of the files there, you'll find this. And I've explained it there rather nicely with the formula. I'd rather have you do it actually though by way of a thinking process here rather than the formula. Although it can be done by the formula, rather long situation. Better I think to try it this way. If it's doubling every 2 minutes, in 70 minutes it's full. So doubling means that what happened 2 minutes ago? Well, 2 minutes ago it was right here. 2 minutes ago it was half full, wasn't it? 2 minutes ago, half full, and then the next 2 minutes, it's completely full. So working backwards, 2 minutes before, 2 minutes ago, it was half full. Well, how about 2 minutes prior to that? 2 minutes prior to that, right here, it was half of that, wasn't it? Because here, it's 2 minutes prior, in 2 minutes it becomes half, and then 2 more minutes it's totally full. So basically we're going back 4 minutes here. 4 minutes means that if we subtract that 4 minutes from the 70 we started with, 66 minutes ago, or 66 minutes is what it took for us to get 1/4. In 2 more minutes, it was half, and then in 2 more minutes after that, 70 minutes was full. So to answer the question, how long did it take to fill a quarter of the container? It was 66 minutes. 66 minutes for 1/4. 2 more minutes, 68 minutes, it was half, it doubled, and then 2 more minutes after that, it was full, 70 minutes. Again, take a look at I have the nice 3-dimensional pictures there for you also in the files on Canvas, if you'd like to see it there, as well as the A equals to P e to the negative RT. Because we're working backwards, we'll be using that formula. And that'll work for us too. Check to see I've done a fair job, I think, of showing you the steps on that. And number 4. Number 4 says that a deer population in the forest area grows at a rate of 2% monthly. If there are 500 deer in May, how many deer, round to nearest whole number, should you expect by next May or by next year? And environmentalists do this quite a bit. They want to make sure that the deer population can survive, so they want to make sure that a certain number are there and not in excess. Because this is a continuous situation, in fact, I'm asking you to use the exponential growth formula anyhow. The PRE formula is what's used, and we're talking about presently 500 deer, and the E to the R, the rate is 2% per month here, so 2% is 0.02, and notice I mentioned 2% monthly. So actually, if you said 2% per month here, the reason that the 12 is used is because we're talking 12 months. Normally we talk about it in years, but if you put the months there, MO, the months will cancel, and then we're left with 0.02 times 12. So even though it says next May in next year, in fact, we're talking a year, we need to use 12 months because the percentage is given in months and not in years. So 0.02 times 12. That's 0.24. And again, asking you to do a bit of rounding here, that's part of the course. Since our table doesn't have e to the 0.24, e to the 0.25 be fine. So let's use that, e to the 0.25. Again, using your table, your e table, e to the 0.25, about in here, looking at 1.284, we'll use e to the 0.25 as 1.284 times 500. Did the same thing I did in the previous problem. Kind of assigned the 2 zeros here, moved it 2 places, 128.4 times 5. I think that should be about 642 Bambis there, okay? Now, we're talking deer in this particular problem. You can have the thumper one, you can have rabbits on your test, okay? So try to insert a little bit of humor into the math here. In any case, we have about 642 deer for number 4. And let me get this off the board and we'll look at number 5 in just a minute. Number 5 talks about how long will it take the price in the economy to double. And while I'm getting rid of this, you should know what we're talking about here. And you should know what formula to use. And I think really the first part of this is already done. The difficult part, the applications, if you would. The easier part should come from here, using the theory to deal with the logs at this point. So let's hope it's kind of downhill from here. These are the ones you want to take your time on, and then you can kind of go a little more quickly for the others. But you should have enough time to do some review and do a good job on everything here, so don't race through it. I don't think it's a difficult test, but you have to know the information, and especially the rules. We talked quite a bit about the rules in the previous videos, so you should be well versed in those, I think. Proceeding to number 5. How long will it take the price in the economy to double in value if the economy is compounding continuously? Continuous compounding. So you know which one to use. For number 5, we have the T and R in natural log of 2. It says how long. So we're going to talk about this one, T and natural log of 2 over R. How long? Natural log of 2, you should know from the previous problem, 0.693. And the rate we're talking about, the rate we're told is at 0.073. 0.073. Okay? I would probably go ahead and move those 3 places above and below for number 5 and do the division on that. And I think probably about 9.5 should be a good answer, okay? 9.5 years should be a good answer. Again, not expecting to have anything exact here. We're talking approximations anyhow. And 9.4, 9.5, 9.6, but I think 9.5 should be kind of nice for number 5. Number 6. Number 6 says use a change of base formula and a log table to evaluate log of base 8.1 of the number 2.4. I kind of made that smaller, the 8.1, so it's kind of tough to see there. But we're looking for log of base 8.1. It should be down there, and of the number 2.4. And I showed you in a previous video how to proceed with this, how we could set this equal to x and go back through the exponential situation and then take the log of both sides. And basically what happens is the mechanics is that we draw a line here and say, look, we use the log base 10 and find the log of 2.4 and the log of 8.1 and do the division there. So it's kind of straightforward if you know how to do that change of base routine. And for number 6, the log of 2.4 I get as 0.3802, and the log of 8.1 it should be 0.9085. I would probably ask you to go ahead and again round this. Don't expect you to divide 0.3802 by that 0.9085. Because 0.90 and 85, it's very close to 0.9. I would just eliminate that entirely and just divide by 0.9. Move the decimal one place above below and do a bit of division there. When you do that, I think maybe 0.42 should be a good answer, okay? Check to see if that's true, 0.42. And that should be a good answer for us. We get the log of 2.4 from our log table. I go down to 2.4 and over to 0, you will see 0.3802. We get the log of 8.1. Again, mine is back to back, so yours may not be. But on the second page of that, 8.1, it's 8.1 and 0, and that should be 0.9085, exactly what's there. As I say, a bit of rounding, give you a good answer for number 6. And number 7. Number 7 says, again, another kind of a thought question. I want to give you at least 2 of these. Haven't had an opportunity to give you the Thursday challenge problems, so this is where we're getting some of those. Number 7. Number 7 says, if the natural log of 2 is A and the natural log of 5 is B, ln of 2 equals A and ln of 5 equals B. Represent then or express the natural log of 40 in terms of A and B. What's the natural log of 40 in terms of A and B? What I'm asking you to do is to break this down by way of the rules and then proceed to insert A and B in place of natural log of 2 and natural log of 5. I'm not asking you to look for the natural log table, okay? We want the answer in terms of A and B. Back here, you could have a few possibilities. 2 and 20 would work, and maybe 8 and 5, 4 and 10. There are a few possibilities. It doesn't make any difference which one you choose. I'm probably going to choose the 8 and 5. I think that'd be kind of nice. But you can choose whichever one you want. This is, of course, the natural log of 8 times 5. And then the rules indicate that if you're multiplying, you should go ahead and multiply the numbers, same as adding the logs. So basically, this is a natural log of 8 plus a natural log of 5. So without asking you to go through the rules, I'm kind of have to do that. Natural log of 8, again, I have natural log of 5. That's good. I can change that to b very quickly. Natural log of 8 and 2. You should recognize that natural log of 8 to be 2 to the third. And then you know what's going to happen. That 3 should come forward. 3 ln of 2 plus ln of 5, right there. And this will make our change in our substitution. We're told that the natural log of 2 is a, so I'll change that natural log of 2 here, right here, to a, with the 3 out front there. And natural log of 5, we're told, is b, and guess what? There's our answer, okay? Now, I reduced it by way of 8 and 5. Had you chosen 4 and 10, it would work the same way. You'd still have 3a plus b, or if you chose 2 and 20 and any other combination that gives you 40, breaking it down ultimately to 2 and 5, you're going to get 3a plus b. So that's the answer you're looking for number 7, 3a plus b. Number 8. Number 8's a nice easy one. I think I can squeeze it here. There aren't too many steps in this one at all. Number 8 is the exact value of log base 17 of 1. The exact value of log base 17 of 1. That's equal to x, and 17 to the x equals to 1. You know what that has to be. There's nothing else that'll work. And 17 to the 0 is going to give you 1. So basically 0 is our answer there. And really, I wouldn't expect you to show any work on that at all. That's a nice, easy one there, number 8. And number 9, I think, is also a very quick one. Number 9, you should be able to look at and get the answer for. Number 9, it says the natural log of e to the 14th power. You know where the 14 is going? And you should know, we've talked about it. I didn't put it in the left-hand corner this time, but the natural log of e and also log of 10, the common log of 10, both equal to 1. So this is basically 14 times 1, or just 14. Okay, so 14 is a good answer for number 9. Not too much work involved there. As you can see, the first few problems took a bit of work, but these are kind of quick. Number 10 the same way. Number 10, we're going to proceed to say, this is an equation. We just dealt with this in a previous session just recently. The log of base 54 of the number x squared minus 3x is equal to 1. And what we'll do is, because we have log base 54, there's no way I can determine what that is. So we're going to have to go back through the other form. You should know what form this is, the log form. We go back through the exponential form, which says this base 54 raised to this exponent 1 should equal to that number x squared minus 3x. So 54 to the 1 should equal to x squared minus 3x. Get this all equal to 0, x squared minus 3x minus 54 equals 0. And then, of course, how many times have we talked about this, right? It doesn't go away. Factoring, right? Maybe 9 and 6 I think might work. And check to see before you proceed. Will the outside and the inside give you a negative 3x? There's a positive 6x and a negative 9x. Sounds like negative 3x, and the last two negative 54. The first one, x minus 9 equals 0. X is 9 and then negative 6. How about x is 9 and negative 6 for us on those? Going back very quickly, if you put a 9 here, that's 81. And 81 minus 9 times 3, 27. I think you'll find that 81 minus 27 is 54. And in fact, 54 to the first power is in fact 54. Looks great. Let's try negative 6 and negative 6 squared. That's going to be 36 for us. Negative 6 squared. And be careful with the negative 6 here. I'll put it in negative 3 and negative 6. That's going to be a positive 18, isn't it? A positive 18 here. So 36 and 18, hoping that's maybe 54. I think in fact it is, isn't it? Again, log base 4 of 54 should be 1. Two good answers. Normally we'd say check the negative, make sure it works, and it does. So we don't throw it away. If it didn't work, we would have thrown it away. But in this case, we'll keep it because both work. Number 10. Number 11. Trying to do that one here also. 11 is 2 to the 1 minus 3x equals to 128. And this is where we really started the chapter here. We said a nice easy way of doing this is to try to match the bases if you can, or the exponents. And in this case, I have 2 on the left side. Try to match it with 2 on the right. Take a look at 28. And 28, I'm thinking, is 128. Is 2 times 2 is 4, times 2 more 8, times 2 more 16, times 2 more 32, times 2 more 64, times 2 more 64 times 2, I think, is 128. So it looks like we're talking 1, 2, 3, 4, 5, 6, 7, 2 to the 7. So how about 2 to the 1 minus 3x equals to 2 to the 7, okay? That's the easiest way of dealing with these, to try to match the bases and then say the exponents are the same. So if that's the case, then we're going to say the exponents are the same and say that 1 minus 3x should equal to 7. And basically maybe subtract 1 from both sides. If you subtract 1, negative 3x is negative 6. Looks like x should be 2, okay? And we're going to check to see if in fact x is 2 in just a minute here. Let's put a 2 back in here. And in fact, my mistake, I think I missed on that one. That's a positive 6, isn't it? Let's be careful with the signs there. Going a bit too quick here. If I subtract 1 from both sides there, 7 minus 1 is 6. This would be a negative 2. So make sure we squeeze that little negative in there. In fact, let me make it kind of large, or erase the 2 in entirety and get a 2, negative 2 in there. I'm encouraging you to make sure you make big negative signs, so I should do the same. Okay, negative 2. Let's put a negative 2 back here. And check to see if 1 minus 3 times a negative 2, 1 plus 6 is 2 to the 7th, in fact, 128. We just found that a moment ago, didn't we? Looks good. And negative 2 should be a nice answer for us for number 11. Let's see if we can possibly get number 12 in here. Maybe not. Okay, I think we're probably going to have to go ahead and, well, I might be able to do it. Let's see if we try. Let's see if we get 12 in there. Number 12 is log of 6 plus x minus the log of x minus 3 is equal to log of 4. I'm not sure that that's going to work for us or not. Let me be safe on this and go to the other side, okay? I want to try to squeeze as much as I could here without erasing. Erasing takes a bit of time, but for fear that maybe it won't get onto camera and it'll just be wasting our time here, let me go back and put it on this side, okay? So we'll take a break for a minute here while I'm getting the board clean, and we'll come back and look at number 12 here. Number 12 log of 6 plus x minus log of x minus 3 is equal to log of 4. In fact, I'm hoping that maybe you went ahead of me here and probably solved this already even before I get a chance to put it up. You should know that we like to compress this if we can to get log on one side equal to log on the other. Just as we tried to match the bases here, we'll try to match the logs also. And the minus sign here means division. So let's go ahead and say 6 plus x over x minus 3. and that's equal to log of 4. And now, we're not going to divide by log. That's a common misconception. We're not dividing by log. What we're saying is these are equal. And by virtue of the equal sign, if you see a log on one side, this something here, should equal to a log of that something. The two somethings should be the same. So log of x should equal to log of x. Those two should be the same. So 6 plus x on the left here over x minus 3 should equal to 4. And then from here, you'll probably want to go ahead and just multiply both sides by x minus 3. And this is 6 plus x equals to 4 times x minus 3. 6 plus x, be careful with distributing property again, right? 4x minus 12. I would probably subtract x from both sides and add 12 while we're doing it, okay? I can probably put that in because I can't get much more in this area, I don't think, anyhow. How about subtracting x from both sides here? And probably adding 12, okay? I'm kind of trying to come to the right side here. So let's do that. Add 12 and subtract x. And subtracting the x is adding the 12, 18 here, and 3x. How about x is 6, okay? You will have time to check these. Do a good job of checking, okay? Take a little bit of time. X is 6. If you put a 6 back, maybe in here, I mean, I think it's pretty obvious right there. Putting a 6 here in both cases for x, a 6 here and a 6 there. 6 plus 6, 12, and that's a log of 12 over 3. Log of 12 over 3 is the log of 12 over 3, the same as the log of 4. Absolutely. Good answer, okay? It doesn't take long to check. Go back and do that, okay? That's number 12. Proceeding to 13. 13, we're looking for 6 to the x equals 216. Probably one of the easiest problems on the page here. It doesn't look like it's the easiest, but it is. We'll do the same thing we did back in the previous one, back in number 11. If you proceed to try to get 6 to some power, we're hoping that works. If it doesn't, we'll take the log of both sides or the natural log of both sides. But the first step is to try to get maybe the base is the same if you can, okay? I know that 6 squared is 36, and I'm hoping that 36 times 6 might be 216, I don't know. Check to see, I think we're right on that one, okay? I think 6 times 6 is 36, and 18 and 3 more, 21. I think that's good. That should be very nice. I think it's 6 to the third. How about x is 3? Okay, a nice, easy problem, okay? Do the first step, the easiest step, try that first. Try to get the bases the same. In this case, the base is 6. It worked very nicely. If it does, we're finished, and that's all there is to it. Okay, there's 13. 14 is the only one that you really need to use the table for to break this down, the natural log of 250, okay? So what we'll have to do is, we'll have to proceed to change this to scientific notation and use our natural log table. This is x equals to natural log of 2.5 plus, actually I should put 100 in here, I guess, and moving it 2 places. And then this is natural log of 2.5 plus the natural log of 100. How about 10 to the second, okay? Because I'm going to find the natural log of 2.5 in a moment here. I'm going to bring this 2 forward and find the natural log of 10. And just put those together and we're finished. It's kind of a simple arithmetic problem. But you have to break it down by way of the rules, and that's what's happening here. The natural log of 2.5. Natural log of 2.5, here's my natural log table. And looking at 2.5, it looks like a 0.0916 for that one. 0.0916. And then how about natural log of 10? I think I know is 2.303. I'm going to check that in a minute though. 303. Let's go back and check that. Natural log of 2.5, 2.5 right here, 0.916, 0.916. And the natural log of 10 should be on the back in my case, in the second page in yours if you didn't do it back to back. Natural log of 10.0 is 2.303. That's 4.606. And add 0.916 to that, and I'm getting, I think, about 4.606 and 0.916. How about 5.522, okay? 5.522. Should be a nice answer for us. Number 14. Number 15 is probably one of the more involved ones on the page. We've done it a few times now, but I'm not sure how well you understood it. It's 4 to the x minus 2 to the x minus 42 equals 0, okay? And in this case, I am going to try to factor it again. You could do this, change your variable, let 2 to the x equal y, and this would equal to y squared. You could do it that way. I'm thinking that maybe just 2 to the x and 2 to the x might work. And then for 42, 6 and 7, and negative 6, in fact, positive 6 maybe, and then negative 7, okay? Let's see if that works for us. You would say the first 2 to the x times 2 to the x is not 4. When you multiply, you keep the base and add the exponents. Keep the base 2, and x plus x is 2x. This is 2 to the 2x. 2 to the 2x, we can just assign those two. That's 4 to the x, isn't it? The outside is a negative 7 of these 2 to the x's. And the inside is positive 6 of these 2 to the x's. Negative 7 of these 2 to the x's, positive 6 of these 2 to the x's. Again, we're not making it 12. We're not multiplying those. It's 6 2 to the x's, the exponent first before you multiply. So negative 7 plus 6 is negative 1 of these 2 to the x's. And the last two, negative 42. This one we're going to throw away very quickly. 2 to the x equals to negative 6. We know that, look, I'll write it here. 2 to the x equals negative 6. We can't have that. There's no exponent for 2 that'll give me a negative number. 2 to the negative 2 is 1/4. It is not a negative number. Forget that one. That's not going to work. Add 7 to both sides. I get 2 to the x equals 7. Okay? And I think we can handle that one. 2 to the x is 7. In fact, what we'll do at this point is, if 2 to the x is 7, let's go ahead and take the natural log of both sides. We again know the natural log of 2. That's the reason natural log is kind of nice. Natural log of 2 to the x equals natural log of 7. And then what you do is the x will come forward, and you have natural log of 2, and divide by natural log of 2, okay? So I'm going to make this natural log of 7 over natural log of 2. The x would come forward here, and we divide both sides by the natural log of 2. And natural log of 7 will look for, I know the natural log of 2 already. Natural log of 2 is 0.693. 0.693. I hope you know what I'm going to ask you to do with that one. Let me find the natural log of 7 first before we do that. Natural log of 7, I think, is 1.946. Let me check. Natural log of 7 may be right here, and that's 1.946. In fact, 1.946. I do not expect you to divide those numbers. I expect you to, again, do a bit of rounding here and look at 0.693 as 0.7, okay? In fact, in business, the business people move this to place and use a percentage instead. And they call it the rule of 70 in business, okay? We're kind of a little more accurate here, sometimes at least, and we use 0.693, but they use the same formulas for business problems. If you move it one place above and below, we'll get a good answer out of this, I think. And I'm getting something like 2.8, okay? And 2.7, 2.8, 2.9, I'm happy with any of those numbers. Again, we're not asking for anything exact here, just something that's going to come close there. And I think that's close enough for us, okay? 1.946 divided by 0.7 should be 2.8. Okay, that will get us through 15. We have only 5 others to do. And in fact, I think 16 is probably the last one that we'll have to do as far as the work's concerned. There are other problems that are multiple choice. So we have answers there. And I ask you to be careful with those because the right answer is there. Normally in a classroom situation, I'd have students coming to me and saying, look, my answer isn't here. And they'd ask me if maybe I printed the problem correctly. And I'd have to unfortunately tell them, well, maybe your answer isn't right. I want to go back and check, okay? And so I assure you that the answers are correct, or the choices are correct. If you don't get one of the choices, then go back and check, especially your signs, okay? Check the sign. Did you do the sign properly? And of course, check the problem. Did you write the problem correctly? If you didn't write the problem correctly, then obviously you probably can't get the answer either. So a few things to check. One of those answers should be correct. So go back and make sure that you do get one of those, okay? Okay, 16 is the last problem we'll have to worry about. And what I did was, because we didn't have a test in the other chapter, I kind of incorporated some of the problems from that later here. So this is what we'll make up, you might say, for that. So instead of having 2 tests, we'll just have 1. And this should be sufficient for both, okay? We're looking for x again. We're trying to solve this. And to get x, we would normally go back to the other form, although we don't have a base there. And you should know, of course, what the base is if it isn't shown. How about base 10, okay? So this says that this base 10 raised to the 3rd power, remember log's an exponent, and 10 to the 3rd should equal to this number, 4x minus 8. And from here it's really simple. This 1,000, be careful, not 100, okay? 1,000, and that's 4x minus 8. Add 8 to both sides, and maybe 1,008 over here. And lastly, divide by 4. And we divide by 4, and looking at 4 into 10, which goes twice, with 2 left over, and 4 into 20 is 5, and 4 into 8 is 2. I think 252 might be a nice answer for us, okay? And check that and see if that'll work for you. I think 252 might be very nice. You could go back and insert 252 back here. When you multiply 252 times 4, I think you'll get 1,008, if I'm mistaken, check that. 1,008 minus 8 is 1,000. Is 10 to the 30 to 1,000? Absolutely good answer, nice and quick. 16 is an easy problem. Again, I don't usually put these in order of difficulty, so you might find that 16 is a lot easier than some of the others we've done. Going on to 17, our review type problems. Now for 17, we're looking for the oblique asymptote for f of x equals to x squared plus 7 over x minus 3. Oblique asymptote, there are 3 particular asymptotes to consider. One is the vertical asymptote. You should know how to find that by setting the denominator equal to 0. The horizontal asymptote, if there was one, would have to have the exponents the same. These are not. Because this numerator is one more, it's going to be an oblique or a slant asymptote, as your author says. I'm going to divide x minus 3 into x squared plus 7. This could also be done by synthetic division because it's x minus 3. The reason I show you the long division is because had this been x cubed and x squared, then we wouldn't be able to do it by synthetic division. We'd have to do by long division. So might as well make sure you understand the long division. The division here, x times what give you x squared? That's x times x. So we'll use our property, distributive property, the most important one in math here, to say x squared minus 3x. And I have the space between those. Don't put the 7 and the 3x together, not the same. We're going to go ahead and subtract that line. That's our division situation. This becomes 3x plus 7. And then we'll say x times what gives you 3x, x times the 3 there. And we'll multiply that 3 times both the x and the negative 3. And get 3 times x, 3x, and 3 times negative 3, negative 9. Do the subtraction on this line. That'll be a positive 16 here. And really don't care about that. I'm going to go ahead and put that at top side here. Well, we normally say plus 16 over this x minus 3. But our concept here for the asymptote is that as our curve is here and our asymptote gets closer and closer, the larger x gets to the right here, the closer these get. So that the bigger x gets, the farther we go down to the right, the bigger x gets, the smaller that fraction gets, the closer these lines get to each other. Until ultimately that goes to 0, and we're left with just y equal to x plus 3. So y equal to x plus 3 should be the line towards which our curve will tend but never touch, okay? And that's hopefully a choice for us there, y equal to x plus 3. Looking at choice C, in fact, okay? Choice C. The others are way out there. Well, the other ones have a 3. Both of them are x. You should know those are wrong right off the go. The only 2 possibilities would be C and D, and C is the correct one there. So there's the answer C for number 17. 18 is one-to-one. We talked one-to-one in the last chapter, and to say this is one of the problems that we normally would have had in the test had you taken that. So we'll get it here instead. 18 is just one-to-one. Well, you have to know what one-to-one means, and it's a rather easy concept. It says for every x, there's just one y, and for every y, there's just one x. So it has to work both ways. 1 to 1. 1x for 1y and 1y for 1x. I think with just a couple examples here, you could make the picture if you wanted to. It's an x4 curve opening upwards, and negative 5 it's going to be lowered 5. And if if you understand what the curve looks like, maybe something like that. Obviously, right there for that particular y, there are two x's and no right off the go here. But you might want to consider it instead of that way. If you didn't know the picture, you don't have to use the picture. Just try some numbers. And I would try very easy numbers like 1 and negative 1. If you let x be 1, I'm going to let x be negative 1. Okay? Let's see what happens. Very quick. It doesn't take too long to do that. If x is 1 and if x is negative 1. Remember now, for every x, just one y, and for every y, just one x. Here, if x is 1, 1 to the 4th is 1, times 3 is just 3. How about a negative 2 on that one, okay? Negative 2. Let's try this one. Negative 1 to the 4th, also 1 times 3, minus 5. Negative 2 there also. Okay, take a look then. For this particular y, negative 2, we have two different x's, don't we? X could be 1, x could be a negative 1. And therefore, even though for every x there's just one y, for every y, or at least for this particular y at negative 2, there are two different x's. So this is a no for us, okay? And I ask you to choose A or B on that one. So let's say B on this one, B and no, okay? There's our answer, number 18. Number 19, find the vertex of this parabola. 19, and the parabola is f of x equals to negative 8x squared and plus 4x minus 5. To find the vertex, you could complete the square on this. Because of the negative 8, I'd probably go the other route. I'd probably use the formula v and negative b over 2a, comma f of negative b over 2a, okay? Try that. This negative 8 being a, and 4 being b, and of course negative 5 is c, which we're not going to be using. Negative b, and back here, v, negative is part of the formula, and positive 4. Positive 4 there is our b, over 2, and times a, and a in this case is negative 8. How about negative 4 over negative 16? That sound okay? And I'm thinking 1/4 should be a good situation there, 1/4. I would really stop right here at this point and check to see what, because the choices are there, do you have only one choice is 1/4? And in fact, you do. So 1/4 and negative 9/2 should be a good answer. But let's check to be certain. This is x. To get the y, we'll go back here. This is our y now. We're looking for f of 1/4. And the negative b over 2a is 1/4. So we're looking at that. We're looking for f of 1/4. And to find f of 1/4, we'll just go back here and replace x with 1/4 in both cases. Okay. So I'm going to do that and erase a little space here. And say this is negative 8, and we said that x was 1/4. I'm going to square that in just a minute. Plus 4, and x also 1/4 over here, and then minus 5. 1/4 squared is 1/16. So it's negative 8 times 1/16, negative 8/16 there in this case. And this is plus 1, and then minus 5. Looking at negative 1/2, plus 1 minus 5. How about negative 5.5 with our negatives? Negative 5.5 plus 1. That should be, I think, negative 4.5. And it isn't expressed that way in the choice. But if you multiply 2 times 4 and 1 more, negative 9/2, negative 9/2 I think should work for us. And that was, in fact, choice B, wasn't it? Okay. So how about choice B is a good answer right there for number 19. And need one more, number 20. And number 20 is a situation of the composite functions. And I'll need a little more space for that. So let me go back and try to erase this first one at least. And we'll squeeze number 20 here and say we've done it. Number 20. 20 says we're given f of x as x squared minus x plus 6, and we're given g of x also as x squared. We like to find this, we like to find f circle g of negative 3. Now be careful, if your test happens to say g circle f, then proceed with that one. Be careful how it's written there. This says f circle g of negative 3, so we'll go ahead and do that, f circle g of negative 3, and see what happens here. If you don't understand it this way, you might use the alternate approach. This f circle g is f of the g of negative 3. And some students like that better because it conforms very nicely to our algebra situation. We should work inside the grouping symbols first. So you should find g of negative 3 first. G of negative 3, go back here to g of x, and replace the x in both cases with a negative 3. And again, you shouldn't have to do all the work I'm doing here. You should know that negative 3 squared is 9 very quickly there. So let's get g of negative 3 is 9. Replace this negative 3 with a 9 right there. What we're looking for now is we're looking for f of 9. So we'll go back to our f function right here, x squared minus x plus 6, and we'll insert in place of that x, we'll put a 9, okay? Let's put a 9 here in place of x, and a 9 here in place of x, and a 9 here. 9 squared, 81, minus 9 plus 6. The positives there, 87 minus 9. 87 minus 9, I'm thinking it's maybe 70, 70, let's see, 9, what do you think, 78 maybe on that one? Sound good? 78? Is 78 a choice? I'm looking at 90, 78, 18, it looks like B, how about that, okay? Let's go for B on that one. Be a good answer for us. And we're finished with that, okay? And this is what the test will look like, the 20 problems. You'll be taking this online, and what will happen is it's timed, which means that you won't be able to access it until a certain day and time. You can check there on the assignments that you see the 2 tests and the final. When it's ready for you to take, it'll pop right up for you. Just click on it, it'll pop up. And I ask you to maybe have a Scantron available. Excuse me, not a Scantron, but the answer sheets available. I have those on the file, so copy a few of those off if you would. And use your answer sheets to work the information here. You might want to put all the answers on one answer sheet and then maybe the work on the others if you like. And then ask you to scan those into your computer, send them to me, and then I'll grade them and give you back the results when I finish, okay? So do a good job on the review here and also on the test, okay? This is session 22, the pre-test for chapter 3, and we're finished. And we'll see you back for the next pre-test. Take care.
That's all done, Rick.